I look at chapter 11 review here. Number one, given a polygon has 6 vertices and 12 edges, how many faces does the polygon have? So we're using Euler's formula. So F plus V equals your edges plus 2. So on this one, we have 6 vertices, 6. We have 12 edges. So F plus 6 equals 12 plus 2. We get F plus 6 equals 14. Subtract your 6 from both sides. F equals 8. So our answer on this one is 8. To make sure, we need to memorize, we need to know Euler's formula there. F plus V equals E plus 2. Next one here, number 2. Match each solid to the space figure formed by rotating about the axis of rotation. So on this, remember, anytime we rotate a 2D shape, like A here, a rectangle, it's going to make a circular figure. So this is going to wrap around and be circular. This point is going to wrap around and be circular. So we get a cylinder type shape. Kind of hard to draw with being so big. So A is going to be a cylinder. B, we have kind of a triangular shape. And so a triangular shape, remember, we always get a cone when we do this because this point doesn't move, but this point's going to wrap around. So there's our cone shape. So B is a cone. And then obviously, only one left, so C has to be a hemisphere. So this is going to get rotated around left to right horizontally, so that's going to give us a hemisphere. If it went vertically rotation, it'd probably be just a sphere. 3, a plane intersects the prism parallel to the base. That's key. Anytime it's parallel to the base, that means it's going to be the same as the base. So if I cut this thing right along the sides here, so in a parallel section, I'm going to get the same section as the base, so pentagon. What is the radius of a hemisphere with a volume given there? So think, what's the radius of a hemisphere? Hemisphere, that's a half a sphere. If it has a volume of 281,250 pi, we can use our formula sheet. On our formula sheet, if we go to the back, there's our formula, 4/3 pi r cubed. Now, since it's a hemisphere, it's half of that. So we can divide this whole thing by 2. Now we start plugging in, and really, we know our volume, so let's move this over a little bit. We know our volume is given at right here, so we can say that equals this. I don't have much room here, 281,250 pi equals my green formula there. The first thing we can do is multiply by 2, or easiest, we just type these 2 in to Desmos. So it was 281,250 pi, and then my other part was 4 divided by 3 pi. Instead of r, remember we like to use x in Desmos, so x to the 3rd power divided by 2. So you see I use parentheses there, so I get that whole divided by 2. Now this one didn't graph anything, so remember it's just a number, so y equals. Now I can zoom out until I see, and I'm about to zoom out for a long while because that 281,000 pi, I need to go to 281. And there is what we want. So 75. So make sure when you do this, you can see sometimes it looks like 0. So maybe you want to zoom in on this and make sure you're not getting where it hits the y-axis. And so you can see this is the point I want. 75 is my answer, not the one where it hits the y-axis. So this is what we want. 75 is our answer for that one. So guys, make sure the only thing really trick is hemisphere. I had to divide the sphere equation by 2. And then we let Desmos do the work. Number 5, a plane intersects the center of a sphere with a volume of about 9,202.8 meters cubed. What is the area of cross section round to the nearest 10? So again, first we need to pick out what shape. The shape is a sphere. So back to our sphere formula. Volume equals 4/3 pi r cubed. And it tells us our volume. So on this one, again, we plug in volume 9,202.8 equals 4/3 pi r cubed. Now, if I want to find out what r is, then I just plug in the left side and the right side into Desmos, just like we did. And I'll leave y in there, 9,202.8. And then down here, I need to take away the 2. And I don't need the parentheses. So again, I need to go to 9,000 because that's what that number is. And see my red line. So 13 is my radius. Now it didn't ask for radius, so r equals 13. That is good to know. We need that. It's asking, says, what is the area of the cross section? Well, if we have a sphere, so if we have a sphere and we want a cross section of a sphere and we cut it, it's going to be a circle. So basically they're saying, what is the area of the circle? So back to Desmos. Sorry, I put 3. It should have been 13. I was saying that looked weird. So this should be 13, not 3. So area of the circle, well, if you don't know it, you come up here, cross-section area, or 2 dimensions, so we're picking one of these, pi r squared. So pi r squared, pi r squared, but we just found out our r is 13, so we're going to plug in 13. So our answer is 530.9. It says round to the nearest 10, so we are going to keep it at 530.9. The 2 tells us keep the 9 the same. So our overall answer for the area is 530.9. So again, plug in the volume for V, solve for the radius, do that by Desmos. You can do that by hand, but a little tricky. After we do that, then we need to plug into the area formula of pi r squared using this r value. Let's jump up to number 6. For each row in the table, could a polygon exist with a given number of faces, vertices, and edges? So again, F plus B equals E plus 2. 8 plus 10 is 18. If we would add 2 to this column, that'd give me 16, so no. 18 does not equal 16. 14 and 9 gives us 23. 21 plus 2 is 23, so yes, that checks off our formula, Euler's formula. We get 14. 12 plus 2 is 14, so yes, Euler's formula does work. So it's no, yes, yes. Assuming the soap bubble is a perfect sphere, what is the diameter of the bubble containing 1,200 centimeters cubed of air to the nearest tenth of a centimeter? So make sure when you do this, circle these, write this down, do whatever you need to do. Well, we need diameter. So don't get tricked and put the radius. We want the diameter. So again, we've used this formula a ton of times, but I just want to make sure. There is our sphere formula. B equals 4/3 pi r cubed. B equals 4/3 pi r to the third power. So they tell me my volume is 1200 equals 4/3 pi r to the third power. And sorry, that's a 3 there. So again, plug this in, let Desmos do the work. You can do it by hand. And I already have 4/3 pi r cubed, x is my r value. And then here I just need to plug in the 1200. Remember, we have y equals. Let's just go home and zoom out. Zoom back in just to make sure we don't pick where it hits the line, because a lot of times when we click on that point, it'll give us the 0. We don't want that. We want this one. So our answer, this is what? This is the radius x. So if x is, let's say, 6.6 round to the nearest tenth. So if r equals 6.6, what is my diameter? Well, remember, a diameter is all the way across. So if this is 6.6, and this left side is 6.6, I have two 6.6. So I'm just going to multiply this by 2. And so we get our answer as 13.2 for the diameter. Just be careful what they're asking. Radius, diameter, they try to trick you sometimes, or they just mix it up a lot, so be careful. Which best compares the volume of the two cylinders? So on this, we look at a couple things, and we look at the height. The height is the same. They're both h. The radius is the same. So the only thing different is we call this one oblique. So it's just pushed to the side, but we've talked about this in class. It doesn't matter if it's oblique or like this one, if it's right, they have the same volume as long as these two, the height and the radius, are the same. So looking through here, A, the volume of the cylinder A is the same as the volume of cylinder B. Check, that is our answer. So A is our answer because they have the same measurements. Number 9, a steel pipe, 100 centimeters long, has an outside diameter of 2 centimeters and an inside diameter of 1.8. If the density of the steel is 7.8 grams per centimeter cubed, what is the mass of the pipe to the nearest gram? So this one's kind of tricky, but when you think of a pipe, and it's talking about an outside, inside, think of a pipe. We have inside and then the outside. So basically, we are doing the diameter, and we're going to do the formula for cylinder twice. We're going to do the formula with 2 centimeters, and then we're going to cut out the inside, because the inside of a pipe is hollow. There's all that part. So we're going to do the cylinder, and we're going to subtract the 2. So again, they try to trick us a little bit. Diameter is 2. Diameter is 1.8. So instead of those, we don't use those in our formula. So let's just first write our formula out. So outside, I'm going to put out for outside. We have the formula pi. Let's flip over just to make sure we're good. Our cylinder, pi r squared h. So we're using this. So putting that up a little bit. Pi. Now radius, if my diameter is 2, then the radius is half of that, the radius would be 1. So pi 1 squared times, and the h is the same for both, 100. Now for my inside, I'm going to subtract that out. If the diameter is 1.8, then we cut that in half. And obviously you can use decimals, but half of 1.8 would be 0.9. So it'd be pi radius 0.9 squared times 100. So it's pi r squared times h minus pi r squared times h, using the r of outside minus r of inside. So let's type all that in. So pi times 1 squared times 100 minus, and I'm going to put parentheses around the second. I could have did the first also. Pi times 0.9 to the second power times 100. And so we get an answer of 59.690. That is the volume of the metal pipe. But also, they didn't just say what's the volume of the metal pipe. They also gave us the density of the steel is 7.8. So for every 1 volume, we have 7.8 grams per centimeter cube. So we need to take that and multiply to find our density. So 59.69 times 7.8. So our answer is 465.58. And it says to the nearest gram, so that means I'm rounding to this. So this 5 tells me to bump this up to 466. So our answer, our overall answer for this one is 466 grams. Number 10, the volume of the prism A is 48. The volume of prism B is half the volume of prism A. What is the value of A? This one's 48. This one is half. So I know we're all good at math here, but 48 divided by 2, so 24 is the volume of our other figure. So how do we find the volume of a prism? Volume equals big B times H. Remember, big B is area of the base. So that's length times width. So this is really length times width times height. So volume equals length times width times height. 24 is our volume. The length is 3 times the width 4 times the height A.
Most of you can solve that. I'm gonna still do good old Desmos because it's just easy.
So y equals 24, the left side equation, 3 times 4 times, instead of a, I'm using x. And then I'm just looking to see where these two cross. So zoom out, and we can see our answer is 2. So x equals 2. Also, guys, once you get here, you could, we have, this is a multiple choice test. You can plug these 4 answers in for A and see which one equals 24. So remember, that's always a good trick when you have multiple choice, is plug and see which one equals. 11, a stack of 1 dozen cookies of diameter 5 inches exactly fits in a cylinder container with the volume given. Which is the thickness of the cookie? So on this one, our volume of a cylinder volume equals pi r squared h. So use the formula sheet. Now diameter is 5, which means our radius is 2.5. Remember, our radius is always half of the diameter. So now we plug in. B is going to be your 176.715. 176.715. And then we have pi times our radius, we said was half of 5. And then times our height, which our height is what we're trying to figure out. What is our height? We need the height to find the answer, so that's our x value. Again, if graphed or did not graph, so I need to put y equals. So our height is 9. So back over here, we get our height of the container is 9. Which is the thickness? Well, it said we have a dozen cookies. So if we have a dozen cookies that fit into a height of 9, then we need to divide. What is 9 inches divided by 12 cookies? Most of you could do that in your head, but if not, 9 divided by 12, each cookie is 0.75 of an inch. And there's our best answer. So you see how these are getting tricky? You're using the volume formula. We have to cut the diameter in half. That's one trick. Next, we're solving the equation backwards. So we got to plug in the Desmos. We got to know this is our volume because it's inches cubed. So that's why it's the B. And then last, another trick is we have to do it per each cookie. So we have to take the height and divide by how many cookies. There's a couple tricks in that one. Make sure you slow down and write everything out. Number 12, for the regular octahedron, each edge has a length of 3 centimeters and the height is 3 square root of 2 over 2. What is the volume of the octahedron? So really, our brains have to think this is just a pyramid. So this is a pyramid stacked on another pyramid. So I'm doing 2 times the pyramid formula. Let's just go make sure we all remember it. A pyramid goes up to a point 1/3 big BH. And 1/3 big B, remember big B is length times width, and then times H. Now let's put in what these are. So it says, what is the height? Well, the height is given right here. So we know this is H. And then our length and width are the same. They're both, it says 3. So right here it says the length and width is 3. So this is 3 and this is 3. So now we're just going to plug that in. Why do we have the 2 out front? Because we have a pyramid on top and a pyramid on bottom that are congruent. So we have 2 times 1 of the pyramids. So 2, because there's 2 pyramids, 1/3. Length was 3, width was 3, and the height was that weird number. It was the 3 square root of 2 divided by 2. So make sure when you do divide by 2, it goes to the 3 squared, do not just some people do this. That's not what we want. So make sure this looks the same. Use your arrow key to arrow out. And so we get 12.727. And make sure it says round to the nearest hundred. So that would be this 2. What's to the right of it is a 7, tells us to bump that up to a 3, to 12.73. Centimeters cubed. That's the answer there. Last couple here. What is the volume of cone? Cone formula, 1/3 pi r squared h. One-third pi, there's our r, and there's our height. That's an easy one, type it in. One-third pi, 5.1 squared, h, which is what, 7.2. So 196.11. That's just a find the formula, put your numbers in, no tricks there. That's an easy, there, get that problem. Which best compares the volume of cone A and cone B? So we can see that if we write this out, the volume for this one, and we just did 1/3 pi r squared. So in this case, here's our r value, r squared times here's our height, times 2r. So if I combine that, well, we won't combine it yet. We'll write out the other formula. So here, volume equals 1/3 pi. Here's my r value. So it's 2r squared. And then here is my height times r. So if we look at this, let's cross some things out here. Let's go a different color I didn't use. Let's go purple. So here I have an r I can cross out, they're the same. I have an r squared. I have that r squared. Now this 2 goes also to the 2, so I can't forget that. I have 1/3, 1/3, pi, pi. So everything's the same other than here I have a 2. Here I have a 2 squared. And we know 2 squared is 4. So really down here, this is 4, and this is just a 2. So that tells me that the volume of B is double that of volume of A, because 4 is double 2. So the volume of A is half the volume of B. So yeah, 2 is half of 4, so A is our answer. 16, a pile of earth removed from an excavation is a cone measuring 6 feet high and 30 feet across at the base. How many trips will it take to haul away the earth using a dump truck with a capacity of 9 cubic yards? So first we need to find the cone formula and use a cone formula. Volume equals 1/3 pi r squared h. So after we solve that, r, 30 across its base, we got to cut that in half. So this is where they try to trick you. The radius is 15, half of 30. So 1/3 pi 15 squared. And then h, it says the height is 6, so times 6. So I could just use that I already had, but 1/3 pi 15 squared times 6. So that's the volume. And now, here's where they tried to trick us. In this problem, it says cubic yards. This is feet, and this is feet. So the trick here is I need to convert all these to yards, not feet. So we can't use 6. We have to divide this by 3. We have to use 2. Because there's 3 feet equals 1 yard. So we need to convert everything to yards so we can use that 9 at the end. So 15 divided by 3 would be 5 squared. And in the pi, we ought to divide pi because that wasn't anything, and 1/3, that was part of the equation. So this is actually what we should type in. So I just want to show you, they will try to trick you on a couple, make sure yards, feet, we got to have that conversion. And I do believe yards, feet is right there on the formula sheet. So 1 yard equals 3 feet. Let's change this to 5. Let's change this to 2. So 52.35. And so 52.35, and it said 9 cubic yards per truckload. So divide by 9 will tell us how many truckloads. So 5.8. And you can't have 0.8 of a truck, 80% of a truck. You gotta have the next number, so you gotta round up. 8 tells us around 5 up to 6. So our answer there is 6. So 6 truckloads.